All right, welcome back. We're going to work on number 47 through 55, I think. We're going to work on a bunch of trig subs where the trig sub is actually given to us. If you're following along from our textbook, some of the trig subs from the book are incorrect, so they are correct here in the videos, and hopefully I get everything correct. So first step, it gave us our substitution formula. But before we can do that, we need to do a little bit of manipulation to the sine cubed. So we're going to rewrite sine cubed as the integral of sine squared 2x times sine of 2x dx. Now right here I have that sine squared of 2x is equal to 1 minus cosine squared of 2x. So this is the integral of 1 minus cosine squared 2x times sine of 2x dx. Well, that kind of gives me a hint of what I'm going to let u be. I know if I take the derivative of cosine, I'm going to get sine back. So I'm going to let u equal cosine of x, or 2x, cosine of 2x. So I get du is then equal to negative sine of 2x dx times 2. Because of the chain rule. So I don't want this negative sign and I don't want the 2. So I get negative 1/2 du is equal to sine of 2x dx. And notice that the sine of 2x dx, I have that in my integral. So now I'm going to write it with the u sub, and I'm going to get this is the integral of 1 minus u squared times negative 1/2 du. So I go ahead and I factor out the negative 1/2. I get this is the integral of 1 minus u squared du. So now I can go ahead and integrate, and I'm going to get negative 1/2 times u minus 1/3 u cubed plus c. And then from here, I'm going to substitute back cosine of 2x. So I get negative 1/2 cosine 2x minus 1/3 cosine cubed of 2x plus c, and then I distribute in the negative 1/2. And when I do this, watch my negatives. I'm going to actually switch these and distribute at the same time. So I get this is 1/6 cosine cubed of 2x minus 1/2 cosine of 2x plus c. And there we go. That's all there is to it. It's pretty straightforward. All right, moving on to the next problem. And in number 48, you'll notice you have secant to the 4th, and our u sub is going to be secant squared equals 1 plus tangent squared. Keep in mind that that is a Pythagorean identity, so we should know that. And just like every other trig problem, I say if this is a greater power than 2 is to go ahead and simplify it a little bit. So I'm going to rewrite this as secant squared of x times secant squared of x dx. And I'm going to use this substitution, but I'm only going to use it on one of the secants. So this is 1 plus tangent squared of x times secant squared of x dx. And the reason I did that just comes from experience. I know that the derivative of tangent squared, or tangent, is secant squared. So I know I can do something along the lines of that. So I'm going to go ahead and let u equal tangent of x. So I'm going to get, this is the, if I take the derivative, I got to do that. You got to take the derivative. You get secant squared x dx. And then from here, I've got my secant squared right there, and I've got it right here. So then I can rewrite this with the u sub, and I get this is equal to the integral of 1 plus u squared du, and the integral becomes very similar to the one we just did. This is going to be u plus 1/3 u cubed plus c. I'm going to go ahead and plug my u back in, and I get that this is tangent of x plus 1/3 tangent cubed of x plus c. There are other ways to do this. If you wanted, you could actually distribute that out and then make two integrals. That would also work. All right, moving on to number 49. So for number 49, there we have a trig identity that says 2 times sine squared is equal to 1 minus cosine of 2x. So we're going to just directly use that right here. It's pretty straightforward. This is going to be the integral of 1 minus cosine of 2x dx. And then what I'm going to go ahead and do is I'm going to separate this into two integrals. This is going to become the integral of dx minus the integral of cosine of 2x. And so what's going to happen is I'm going to have to do a u sub on this one, and I'm going to have to just integrate the one on the left. So I'm actually going to rewrite this one more time. This is the integral of dx minus, and here's where my u sub comes in. So I'm going to let u equal 2x. So du is equal to 2 dx. And I don't want the 2, so I get 1/2 du is equal to dx. So I'm going to rewrite the integral on the right in green to show the u sub. So this is cosine of u du. And now I can go ahead and just integrate everything. I get this is equal to x minus 1/2 sine of u plus c. But I don't want to have a u in my answer. So I get this is x minus 1/2 sine of 2x plus c. And there we go. All right, number 50, moving on. Here's another 2 times a squared trig function. And we're just going to go ahead and substitute that right in. But before we do that, we need to get rid of this 4 because I only have a 2. So we know 4 is 2 times 2. So I'm going to write this as 2 times the integral of 2 times cosine squared of x dx. So now I can write this as 2 times the integral of 1 plus cosine of 2x dx. And then this integral becomes very similar, but you have to be careful that the 2 is multiplying to the entire integral. So it's 2 bracket the integral of dx plus the integral of cosine of 2x dx. And here's where the u sub comes in, so I'm going to put a 2, the integral of dx plus, and for my u sub, I'm going to let u equal cosine of 2x. I'm sorry, u is just going to be 2x because I don't have a sign. So then du is equal to 2 dx. So 1/2 du is equal to dx. So this is 1/2 the integral of cosine of u du. I'm going to close off those brackets. Now I get this is 2 times the integral of dx is x plus 1/2 sine of u plus c. And again, I could throw that in the parentheses, but 2 times c is just c anyways. So then this becomes 2 bracket x plus 1/2 sine of 2x plus c. And so this is 2x plus sine of 2x plus c. And that will give us our final answer. All right, number 51 says tangent to the 4th dx, and we know that tangent squared is equal to secant squared minus 1. We know that from a trig identity. So again, this is tangent to the 4th. I don't want tangent to the 4th. I want tangent squared. So what I'm going to do is I'm going to write this as tangent squared x times tangent squared x dx. And I'm going to go ahead and use one of my identities to write this as tangent squared of x times secant squared of x minus 1 dx. And there might be a better way to do this. My instinct says to go ahead and distribute this. So I'm going to get the integral of tangent squared x secant squared x minus tangent squared x dx. And I can keep simplifying this because I don't know the integral of tangent squared, but I can write this is the integral of tangent squared of x times secant squared of x minus, and remember tangent squared is secant squared of x minus 1 dx. Keep writing my integral out, distributing that negative, times secant squared of x minus secant squared of x plus 1 dx. And now this just becomes many integrals. So this is equal to the integral of tangent squared x, secant squared x, minus the integral of secant squared x plus the integral of 1 dx. And what I always do is I forget to write my dx's after each integral. It's very important that you do that. So for this first one, it's going to require a u sub, and I'm going to let u equal tangent of x. So du is going to be secant squared of x dx. So when I u sub this, I'm going to get that this is equal to the integral of u squared du, because u is tangent. And then these integrals are just going to follow down like this. And I'm going to get minus the integral of secant squared x dx plus the integral of 1 dx. So when I integrate this, I'm going to get 1/3 u cubed minus tangent of x plus c. And so here I need to u sub back, so I'm going to get this is 1/3 tangent cubed of x minus tangent of x plus c. And now let's do number 52, which I believe is the last problem. So this problem's kind of funny. I actually enjoyed doing this one a lot. Right off the bat, you see that cosine 2x is equal to cosine squared minus sine squared. So some of your instincts might be that this is very close, let's just do it anyways. But you can't do that. So what we have to do then is we have to actually factor. And this becomes cosine squared of x minus sine squared of x times cosine squared of x plus sine squared of x dx. And then using the property, we know that cosine squared minus sine squared is cosine of 2x. So this becomes cosine of 2x. And from trig, we know that this piece right here is equal to 1. So this is our actually entire integral, cosine of 2x. So then it just becomes a very easy u sub. So we let u equal 2x, du equals 2 dx. So 1/2 du is equal to dx. And so we get this is equal to the integral of cosine of u times 1/2 du. So this is 1/2 times the integral of cosine of u du. So we get 1/2 sine of u plus c. And then when you plug back the u in, you get 1/2 sine of 2x plus c. And that's really it.